the Earth has been our home for millions of years. However, sometime soon, the Earth may no longer be our only home, and we will start to spread out, searching for new places to live. It's possible that in the near future, the Earth could become uninhabitable due to climate change or overpopulation.
Sooner or later, here on little planet Earth, we're going to meet an unhappy end.
As a result, we may need to move and create a new home in alternate, distant space colonies.
Really, in the coming years, there will be several activities on the surface of the Moon.
The recent discovery of huge amounts of water in the Moon's poles and on Mars has encouraged public institutions as NASA or the European Space Agency and private companies as SpaceX to lead projects that will let us to settle in such distant and harsh environments in the near future.
We could see Mars colonization in our time. We could see it much sooner than most people think.
Another option might be a future settlement in an orbital space colony, or even on a nearby asteroid. In any case, it's not an easy task at all. We would require habitats, storage facilities, shop workspaces, renewable energy sources, food production spaces, and equipment. In the Moon, we would need to solve huge difficulties such as the low gravity, the exposure to lethal cosmic radiations, or the lack of atmosphere.
You're over 100 degrees Celsius during the lunar day. And then when you go to lunar night, you're minus 180.
In Mars, the difficulties are even more challenging due to the increased distance from Earth, which implies a much longer interplanetary spaceflight of about 6 to 9 months. This is too long for astronauts to be exposed to zero gravity and lethal cosmic radiation. The unstoppable technological breakthroughs suggest that in the near future, we will be able to overcome all these challenges.
That is going to create the greatest industrial revolution in the history of mankind. And we're standing right here at the moment in history when it's about to happen.
Our descendants who might live on the Moon or Mars will remember the moment they established the first space colonies as one of the greatest milestones of humanity. Human beings have always been fascinated by that mysterious dark space outside Earth. The beginning of the colonization of space may be dated to 1957, when a first historic step took place that would mean the beginning of the space race.
In the late 1950s, 1957, the Soviet Union put an artificial satellite on top of one of their nuclear missiles, their ICBMs, and that was Sputnik, later called Sputnik 1.
Just 4 years later, in 1961, Yuri Gagarin became the first human to journey into outer space and to complete an orbital flight.
Technological progression continued so that the rockets got bigger and bigger. They were finally able to do the first moon landing on July 20th, 1969.
Neil Armstrong reached that unbelievable milestone. He was the first human ever to walk on the lunar surface. Just 2 years later, an important new step occurred in the conquest of space. In 1971, the Soviet Union launched Salyut 1, the first manned space station to orbit the Earth. It didn't take long for the United States to launch its own space station, Skylab, which orbited Earth from 1973 to 1979. The next step was the Mir space station. It was a modular space station run by the Soviet Union and later by Russia, which was assembled in orbit from 1986 to 1996. The mission ended in 2001 when it was finally deorbited. It was the first continuously inhabited long-term research space station in orbit ever. In fact, Mir could be considered a precursor to a space colony. 1998 was a key year in the adventure of space colonization. That year, the first component of the International Space Station was launched into orbit. This space station is a joint project among European, Canadian, Japanese, and Russian space agencies and NASA. It is the largest man-made object built in space to date. It has the size of a soccer field with 72 meters length and 108 meters width.
The International Space Station is a wonderful lab, and we can do a lot of science over there, and even more. We can do inspiration to people. We can raise awareness of people by the reports of the astronauts.
Since 2000, astronauts, cosmonauts, and even space tourists from 17 different nations have continuously occupied it.
The beauty of the International Space Station is not only the research done on board, but it's especially the geopolitical aspect of the International Space Station.
All of these space stations might be considered the first steps toward future space colonization, as they have proved that we really are able to survive up there in cold, dark space. Human beings have always felt the impulse to explore and discover new frontiers. From Christopher Columbus, who crossed the ocean to discover America, to Amundsen, who traveled to the South and North Poles. There have always been intrepid explorers that dared to go one step forward to see new worlds. Now, our next frontier beyond the Earth is somewhere orbiting the Earth, or on the surfaces of the Moon, Mars, or even asteroids.
Human beings have always had the destiny of flight in their minds. And over the last 100 years, we've conquered it flying on Earth, and in the next 100 years, we'll conquer it in space.
In addition to the innate curiosity that leads human beings to always go one step further, there are other reasons to find new places to colonize beyond the Earth. The first of them is that we might really have the need, in case our own planet deteriorates so much that we can no longer live on it.
Probably most important reason why we should go into space is to safeguard our own existence. Because sooner or later, here on little planet Earth, we're going to meet an unhappy end.
People like Stephen Hawking, the well-known astrophysicist, and so many others have predicted that if we don't have human settlements in space, the future of humanity on Earth is in danger.
One of the biggest hazards that humanity might face would be the impact of a large asteroid.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
If an asteroid were 5 miles wide, it would cause major extinctions, like the one that may have marked the end of the age of dinosaurs. There is also the possibility of a massive man-made disaster that might obligate us to leave the Earth, as climate change or industry-linked disasters. Climate change is one of the biggest menaces we are facing nowadays. In a quite short period of time, it could cause a huge humanitarian disaster affecting millions of people. On another front, overpopulation is also threatening our civilization. As a future scenario of scarcity approaches in which there won't be enough resources for the Earth's population. In such situations, having an alternative place to live could be the only way for our civilizations to survive. But there is also a huge, powerful reason that encourages human beings to go beyond the Earth. Space colonization will bring us a new, huge industry created around new resources found off the Earth. Resources in space, both in materials and energy, are enormous. And we know that, sooner or later, we will run out of resources here on Earth as they are scarce and limited.
All the resources humans need on Earth are now in space. We have the science and the technology. We know we can capture them.
The solar system alone has, according to different estimates, enough material and energy to support anywhere from several thousand to over 1 billion times that of the current Earth-based human population.
For now, a tiny fraction of the asteroid belt is more than enough to supply a virtually unlimited material for space industrialization and space colonization.
Harnessing these resources could lead to much economic development.
At some point in the next 100 years, I expect the economy in orbit will be bigger than the economy on the ground. There's more space there. There's more material that's accessible. And there's no gravity. You can do more interesting industrial processes.
The fact that we are exploiting and using expendable resources on Earth, and those resources that are out there in space, makes the obvious conclusion we have to go.
The building of a space colony would present a series of huge technological and economic challenges. A space colony would have to be self-sufficient to be able to serve thousands of humans in an environment very hostile to human beings. Depending on the location of the space colony, whether in orbit or planet-based, there are two main types. The first type would be the space habitats, or the orbital colonies.
An orbital space colony or space settlement is in orbit. So it's actually orbiting around the sun or around the Earth or around the moon in what's sometimes called free space or low Earth orbit.
The International Space Station, or the former Mir Space Station, could be considered as precursors of these orbital space habitats. A second type of colonies would be the surface-based colonies that would exist on the surfaces of planets, moons, or asteroids. Although nowadays it seems that surface-based colonies are the best option, there are, however, certain reasons to support the building of an orbital colony. A space colony in orbit around the Earth would have many important advantages over the surface-based colonies on the Moon, or on Mars, or on asteroids. The first advantage is the proximity to Earth. Travel back and forth to Earth should take only a few hours. Bringing supplies, materials, and specialized equipment from Earth to support construction would be relatively easy. In addition, there's another advantage to being close to the Earth: the protection from cosmic radiation that is provided by the Earth's magnetic field.
If you put your orbital settlement in exactly the right place, namely directly over the Earth's equator, not more than 500, 600, 700 kilometers high, you're protected by the Earth's magnetic field. And the total amount of radiation is much, much, much lower in low Earth orbit over the equator than it is on the surface of the Moon or Mars.
However, in a very high orbit around Earth, far from the protection of Earth's atmosphere and magnetosphere, or around the Moon or Mars or an asteroid, the hazard of radiation would be extremely high. Those settlers would suffer long-term exposure to dangerously high doses of radiation. Another pro of the orbital space colonies would be the continuous, ample, reliable solar energy. In a high enough orbit, there is no night. Solar power is available 24/7 in most high orbits. Although in high, low Earth orbit, there is some darkness during each orbit as a structure passes through the Earth's shadow.
Depending on what orbit you're in, you may have better access to solar energy. Not so much in low Earth orbit, but if you're in higher orbits, you have access to solar energy.
Solar panels for settlements would have to be huge in order to generate enough power. This power might be generated on separate solar power satellites and beamed to the settlement. The construction of these structures would be weightless. Zero-gravity construction means big settlements can be built with relative ease.
Some of the advantages of orbital settlement are it's a little easier to build larger things because you're operating in microgravity.
Under zero-gravity conditions, several industrial processes can be done much more easily than on Earth. Astronauts are able to move very heavy objects, up to a few tons of weight, without any help. Therefore, the lack of gravity would radically facilitate the construction of a round structure that was several miles high without its collapsing under its own weight. A near-Earth orbital colony could also generate important economic development as it encourages new energy or tourism markets. When these future orbital space settlements grow, they would be like cities in space, places where people could live and raise children. However, these orbital settlements would have several cons.
The biggest con for orbital settlement versus surface settlements is access to materials. There aren't any materials in orbit at all.
Another con would be the permanent lack of gravity, or the microgravity, that is the gravity force one experiments in low Earth orbit, as happens in the International Space Station. The lack of gravity has very negative effects on human health, such as bone and muscle loss, vision disorders, or headaches. One solution might be to build huge circular structures that spin and create at least a sense of gravity. This artificial gravity would be created using a centripetal force. In the context of a rotating space station, it would be the spacecraft hull that provides the necessary centripetal force to simulate gravity.
So it's the concept that this thing is going to be spun at a certain rate to create a sense of gravity, which again is not a real gravity. As a matter of fact, the only thing that feels gravity is a part that's pushing against the outer surface.
There are many proposed designs and concepts for orbital space colonies. However, unfortunately, as of today, no specific project has yet been developed. There is another type of space colony, the surface-based colonies that would exist on or below the surfaces of planets, moons, or asteroids. The situation regarding these is very different compared to orbital space colonies, as there are several future plans for them. In fact, in 2010, NASA approved a very ambitious program called A Journey to Mars, whose ultimate goal is to send humans to Mars in the 2030s. In addition, ESA, the European Space Agency, has an exciting concept for a future human settlement on the Moon, the Moon Village.
There are developments underway with NASA, like the Space Launch System and the Orion capsule, to put astronauts in orbit around Mars in the 2030s.
Engineers and scientists are working hard to develop the technologies astronauts will use to one day live and work on Mars and safely return home from the next giant leap for human.
The challenges of doing a human expedition are extraordinary compared to robotic expeditions. You need to launch heavy vehicles from the Earth. You need habitat in transit from the Earth to Mars. You need propulsion to speed the rate of travel up, because it takes typically 6 months. And there's a lot of radiation from galactic cosmic rays and solar flares that are just not good for astronauts that we don't know how to shield currently.
International space agencies collaborate with the commercial space industry, such as SpaceX or Blue Origin, on coordinated expansion of human presence in the solar system, with human missions to the surface of Mars as the main goal.
And lastly, what's new in space is the proof that public-private partnership works in space. When private industry has to pay some of the costs, they're much more efficient. You get the efficiency of the private sector, you get the deep pockets of the government, and you do fantastic things.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that are involved to just go for it.
This collaboration between private companies such as SpaceX and public institutions will soon produce great results in the adventure of the colonization of Mars.
So these people, the Jeff Bezos, the Elon Musks of the world, are very serious about making space work for humanity and do good for humanity back here on the Earth.
Unbelievable advances in science and technology have allowed us to achieve milestones unimaginable in the past. Regarding the Moon, everything seems to indicate that we will be witness to great advances very soon. In April 2016, Johann Dietrich Warner, Director General of the European Space Agency, surprised with the announcement of an amazing concept: the Moon Village.
The Moon Village is not a project. It is an open concept with free and open access for each and everyone, be it industry, be it the public sector. It is open for robotic activities, it's open for human activities.
It is clear that in the future, humans will take part in crewed flights farther into the solar system, so the Moon Village could also act as the perfect springboard and testing ground with that objective in mind.
I believe that the Moon Village is already in its development phase, and it's only a question of a month or let's say 1 or 2 years that we really see hardware on the Moon belonging to the Moon Village.
Building and inhabiting future planet-based space colonies means a huge technological challenge, very different from orbital space colonies. Building colonies in space would require access to water, food, space, people, construction materials, energy, transportation, communications, life support, simulated gravity, radiation protection, and capital investment.
Life support for a permanent settlement, we see in the movies that there are plants up there creating oxygen and biomass and food, and you would need that.
We're going to want to set up greenhouses, and we will take the carbon dioxide that we breathe out and some of the water that we produce, and we will use it to grow plants, and they'll turn it back into oxygen and into food for the colonists to eat.
The colonies should be located near the necessary physical resources because launching materials from Earth would be expensive. A fundamental need for the maintenance and sustainability of such space settlements would be the source of energy.
You have basically two choices at first, which is solar energy or nuclear energy.
When it comes to think about an abundant and reliable energy that we might use in a colony in the Moon or in Mars, we first think about the solar energy.
Your energy source is the sun, this enormous fusion reactor. You can't turn it off. At Earth orbit, it's supplying you with 1.377 kilowatts per square meter continuously, forever, completely reliably.
The distance of the sun is the main problem, as Mars is further away than Earth. So light intensity is much lower, and the solar energy we could benefit from is also lower. In addition to solar arrays that would need to be on the surface, there might also be large solar power satellites that would use wireless power transmission to send power to colonies on the Moon, on Mars, or other locations in space. But in places like the Moon or Mars, solar power implies another difficulty. As the supply of solar energy is too discontinuous in these locations because the moon night is 2 Earth weeks long. And on Mars, you have an atmosphere featuring large dust storms that would cover and degrade solar panels. Therefore, one possible solution could be nuclear energy.
The problem with solar energy on Mars is that it's not completely reliable. You can have a dust storm on Mars that would greatly reduce the solar power for months at a time, which could be fatal to a colony.
But energy sources aren't the only challenge we will have to cope with. Transportation to these future planet-based colonies would be also a difficult issue. Earth's force of gravity is the main obstacle faced when transporting anything to orbit. In fact, it is often the limiting factor in space endeavors.
The cost of human exploration is dominated by the cost of launching rocket propellant from the surface of the Earth up into space.
To settle space, much cheaper launch vehicles are required, as well as a way to avoid serious pollution damage to the Earth's atmosphere from the thousands, perhaps millions, of launches required. A hypersonic spaceplane with an air intake system could be one solution. Its pollution impact would be minimum, as it doesn't use any fossil fuel, but atmospheric oxygen and liquid hydrogen to reach over 5 times the speed of sound, or Mach 5. Another possible solution to make transport easier could be space elevators.
Space elevators are an idea that came about from a Russian progenitor many years ago. The idea is very simple, that if you can erect a structure that is so tall that you don't have to have a rocket ship to carry stuff, instead carry it through a tether or an elevator to the destination.
We will probably need to transport tons of materials from the Moon, from Mars's moons, and near-Earth asteroids to construction facilities located in orbital colonies.
If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration of cislunar space, human exploration of the surface of the Moon, human exploration of asteroids, and even human exploration of Mars.
Another important issue to consider is transport within the colonies. Once we are on the surfaces of the Moon or Mars, we would need local means of transport, such as lunar rovers and Mars rovers to move around.
You need a rover to drive around, to go explore Mars. You need a spacesuit that's light enough for the heavy gravity of Mars.
Not only that, but to get around for excursions, maintenance, or safety, you would need spacesuits, as the Moon, Mars, or asteroids are hostile environments for humans.
The spacesuit people wear is a spaceship to absorb radiation and prevent changes in temperature and pressure.
To establish colonies in such distant, harsh environments as the Moon or Mars will mean overcoming many challenges. Communication for a settlement so distant from Earth would be a key factor. For settlements on the Moon and in orbit, communication is not difficult. In fact, nowadays, a great proportion of current terrestrial communications already passes through satellites. Nevertheless, for future, more distant colonies, communications become a difficult-to-solve issue. Transmissions to and from Mars suffer from significant delays due to the finitude of the speed of light and the greatly varying distance between conjunction and opposition, the closest and the furthest distance between Mars and the Earth.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
Nevertheless, future colonists would have no problem with other means of communication that do not require live interaction, such as email and voicemail systems. Any of the future colonies, whether on Mars, on the Moon, on asteroids, or an orbital space station, is going to mean coping with high levels of radiation, extreme temperatures, the lack of oxygen, and the lack of resources in general. On Earth, we have a perfect life support system supplied by a huge and complex biosphere. In space settlements, which are closed and relatively small systems, if we want to ensure a life support system, we will have to recycle or import all the nutrients to avoid its collapse. The closest terrestrial analogy to space life support is possibly that of a nuclear submarine. The challenge of mechanical life support systems in a nuclear submarine is to support humans in closed, small spaces for months without surfacing. This same technology might be employed for space use. Therefore, building a space colony will undoubtedly be one of the biggest challenges humanity has ever faced.
An expedition that's relatively short-lived for science and then comes back to Earth, that's a little bit easier. But if you want to sustain civilization on the planet, then you have to figure out how to deal with these issues.
There is, however, still one issue without which we won't be able to survive out there: protection from radiation.
In fact, space is a seething cauldron of very dangerous radiation that comes from two sources. One is galactic cosmic radiation that comes from all directions at once, and the other is solar radiation that comes from the sun.
Cosmic radiation is a hazard. So in low Earth orbit in the International Space Station, we're largely protected by Earth's magnetic field. But as soon as you go to deep space, what's happening is there are particles coming in from the cosmos called galactic cosmic rays, and they go right through the spacecraft walls. And sometimes they collide with them into a shower of other particles, basically protons. And they go right through the flesh, and they can disrupt the DNA.
In environments with no protection to that lethal radiation like the outer space, or the Moon's surface where there is no atmosphere at all, or the surface or Mars with an extremely thin atmosphere, the life would be impossible.
The surface of Mars we've studied in many locations, it's so exposed to radiation and ultraviolet light that even organic molecules are completely destroyed.
Settlements as well as spaceships during the long journey to such distant destinations must be surrounded by sufficient water mass or other materials to absorb most incoming radiation to protect life.
So to protect you for this on a colony, you could have a safe haven. Water, I believe, is a good detector. So if you had a space colony, you could arrange, for there to be either safe rooms or the water storage could be in a strategic location.
In addition to all the challenges we have to overcome to get to our destination, there is one other that we must take into account: the effects of spaceflight on human health. If we want to go to a lunar colony, we would need to travel through space for at least 1 or 2 days with present technology. However, to go to Mars, the journey would take much longer, between 6 and 9 months. Such a long spaceflight would mean very long exposure time to cosmic radiation and to zero gravity, with the subsequent negative effects on human health. In addition to that, a mission of such long duration can carry several psychosocial problems. The solitude that astronauts suffer can generate claustrophobia and depression. In the same way, lack of sleep and monotony may affect the correct performance of tasks that in such a demanding work environment would require extreme precision. Most of the detrimental effects on the human body are related to being exposed to the lack of gravity during long space flights. There are significant adverse effects, which include muscle atrophy and deterioration of the skeleton, which is known as spaceflight osteopenia.
We know that 0G for a considerable length of time doesn't work. You end up with a lot of problems.
The top 3 complaints in space for health are headaches, backaches, and poor sleep. I believe in that order, although it's different for everybody.
Other significant effects, including a slowing of cardiovascular system functions, decreased production of red blood cells, balance disorders, eyesight disorders, and a weakening of the immune system.
You don't have the gravity pulling on your bones. So you'll lose, say, 1% of your femur, your hip bone, every month. Just gets absorbed back by your body because you're not using it as much.
And your bones start losing calcium almost immediately and continue to lose calcium throughout the flight, no matter what the duration is.
So you have several liters of fluid from your lower body that float into your upper body. And if you look at the astronauts on TV, you'll see their faces are rounder than they should be. And that's literally extra fluid that's floated from their legs into their upper body.
These effects happen in zero gravity or microgravity, but on the Moon or Mars, there would be some gravity, so consequences on human health would be different.
So the Moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea.
Learning to live outside the Earth will be one of humanity's greatest milestones, and it won't be an easy task at all. Engineers and scientists from all over the world are working to develop the technologies that will lead us to be able to establish our first home off Earth. In fact, there are several projects from public institutions and private companies that will kick off the future real colonization of space. Among all the colonization projects, there are some that have focused on taking advantage of using the resources on asteroids. In fact, these could be considered the first real step toward an imminent future space industrial revolution.
The asteroids are the key to an affordable program of human exploration for our civilization. So the main advantages of the asteroids for human settlements is that they allow us to engineer worlds in space that provide all of the needs for human habitation.
The first aim of the colonization of the asteroids would be the mining. Asteroid mining is a proposed industrial process in which asteroids are mined for valuable materials, as rocket propellant or certain raw materials or metals that are scarce on Earth.
We concluded that the asteroids were the best place to mine for delivering material to Earth orbit.
The asteroids right now are known to be the greatest resource of mineral resources. Economically, one asteroid could produce $1 trillion worth of revenue over a short period of time, mining it and transporting it to Earth. And there are companies seriously planning to go out and capture those. The interesting thing about the asteroids is that that kind of research can combine efforts to avoid asteroid collision with Earth. At the same time, we're mining them to get the resources for Earth.
The asteroids are a goal for space resources for two reasons. One, in terms of the energy and rocket propellant required to get there and back, they're the most accessible targets beyond low Earth orbit for humanity. Two, they have many valuable materials that can be used in space. The first valuable material that we'll harvest from asteroids are the ingredients in rocket propellant. If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration.
The main asteroid belt between the orbits of Mars and Jupiter and the so-called Jupiter Trojans, which are co-orbital with Jupiter, are the places where most of the known asteroids are located. In addition to those asteroids, there are other orbital families of asteroids with important populations, such as the near-Earth asteroids, which have orbits close to Earth. Up to date, several missions have been sent to visit some of these near-Earth asteroids. The first one to be visited by a spacecraft was asteroid 433 Eros, when NASA's Near-Earth Asteroid Rendezvous probe landed on its surface in February 2002. A second near-Earth asteroid, 25143 Itokawa, was visited in 2005 by the Hayabusa mission of the Japan Aerospace Exploration Agency, JAXA.
So the Hayabusa mission, which was performed by JAXA, went out to the asteroid Itokawa, and they actually took a very small sample from the surface of that asteroid. It was a little less than 1 milligram of material.
The fact that asteroids are small rocks floating in space offers several advantages, but also some disadvantages. One of the greatest advantages is their low gravity because of their small size, which means an important reduction in the costs and risks of landing in comparison to the Moon's or Mars's higher gravities. This fact also makes the construction of structures much easier. The fact that there are over 300,000 asteroids identified to date is another pro, as there would be a large number of possible sites.
There are asteroids everywhere in the solar system. I mean, literally everywhere. Not every single location, but there are asteroids here and there.
It's known that there are carbon-rich, metallic, and stony asteroids. This variety in their chemical composition makes them potentially useful as materials for building or fueling spacecrafts. Material mined from asteroids could be a basis for trade economy, and precious metals may even be returned to Earth or other colonized worlds from asteroid mines for economic gain.
And with public-private partnership, we can build the infrastructure that moves industry and space, not in 20 or 50 or 100 years, but starting in 3 or 4 or 5 years. And we can be harvesting rocket propellant in less than 10 years and building the transcontinental railroad to the solar system.
Many asteroids contain large amounts of water and other volatiles, as well as carbon, all of which are necessary for life support.
The ones that we're going to be interested in first are what we call carbonaceous chondritic types. And the magic constituent that they have that we're going to be after is water.
These resources could also be transported to other places in the solar system where they are scarce, and at a much lower cost than launching such materials from larger bodies such as the Moon or Mars.
We get better space propulsion utilizing the asteroid volatile material, the water and carbon dioxide, which we can convert into rocket fuel. We'll have more mobility in space, and as that happens, we'll go further and further into the solar system. And that's the first small industrial scale mission to bring back an economically important quantity of rocket propellant that can change the economics of space.
However, to make this future mining industry a reality, we should solve several challenges, such as the asteroid's low gravity and zero atmosphere, which make them vulnerable to cosmic radiation and to the impact of small objects. There are several private companies interested in mining asteroids. On 2012, the private company Planetary Resources announced a plan to harvest resources from asteroids. The plan has a few opponents who doubt the profitability of the operation, as the cost of extracting resources like precious metals, no matter how abundant they are in the asteroids, would be much higher than its extraction cost on Earth.
There are some materials that potentially could be of use on Earth. Platinum group metals is usually mentioned. It, however, is very difficult, at least now, for asteroid mines to compete with Earth mines.
Nevertheless, Planetary Resources thinks that the plan will be profitable if they are able to develop technologies that reduce the costs of spaceflight. One way to reduce those costs would be the creation of space facilities such as propellant production plants. The asteroid mining company TransAstra is betting strongly on a plan to produce propellant using the water contained in asteroids. Molecules of water would be split into their atoms of hydrogen using solar energy.
TransAstra has a business plan that's focused on extracting rocket propellant from asteroids. You could call that asteroid mining if you want. And then using that rocket propellant to fill refueling stations in space, to refuel NASA spacecraft and private sector spacecraft.
Another very promising asteroid mining company is Deep Space Industries, founded in 2013.
So Deep Space Industries is an asteroid mining company. We expect to be mining asteroids in somewhere in the next 6 to 10 years.
Its goal is to provide the technical resources, capabilities, and system integration required to prospect for harvest, process, manufacture, and market in-space resources.
So when we look at which asteroids that we want to mine, we're looking at several different things. We want to know that they have the materials in them that we can extract and that they're relatively easily extractable. But one of the biggest things is accessibility. They have to be relatively close to the Earth.
Nowadays, there are several projects led by public institutions and private companies, such as SpaceX, Blue Origin, or these asteroid mining companies that show that future expansion of human beings beyond the limits of our planet is not so far in the future.
We stand at a very important time in history. There have been a few important changes that have occurred in the last few years. One, for the first time we know that there's valuable water and other materials in the lunar poles and in the highly accessible asteroids that can be used to make very cost-effective rocket propellant to make it much less expensive to do deep space exploration. 2, we now have the technology to build fully reusable, very affordable spaceships. Elon Musk and Jeff Bezos are leading the way in that way. They're starting off with fully reusable rockets that launch into space. It's very obvious that the next step is fully reusable spaceships that stay in space and fly the space line. But those fully reusable spaceships in space will require rocket propellant, and we'll get that from the lunar poles and the asteroids.
We might be on the verge of witnessing a new whole revolution that will change the world as we know it now. The space colonization race has just begun. Human beings have always felt the need to explore new places. Since their origins, they have spread progressively until they have taken over the whole planet.
We are voyagers, we are explorers, and we are colonizers. We've done this everywhere.
Now, our next frontier could be the moon. Climate change, overpopulation, or the possible impact of a big asteroid could force us to leave the Earth and expand to other places in the solar system. Beyond the Earth, there are a large number of resources that might let us to grow as a civilization.
For now, a tiny fraction of the asteroid belt is more than enough to supply a virtually unlimited material for space industrialization and space colonization.
Human beings know no boundaries. The recent discovery of water on the moon has led to the development of new plans to finally return there. All over the world, several private companies and public institutions are working to make it soon a reality.
In the coming years, there will be several activities on the surface of the moon.
Building a home on the moon will force us to face new challenges such as low gravity, the lack of atmosphere, lethal radiation, and extreme temperatures.
The temperature difference is so great that it actually triggers seismic activity.
We will have to build safe habitats, to design efficient transport, to obtain energy, and to produce food and other needs to supply the future colony. Undoubtedly, the construction of a lunar base would be one of the greatest technological challenges humankind has ever faced. Engineers and scientists are working to begin a new era of manned space exploration. Our generation might be remembered as the first one that managed to settle a lunar colony. The Moon. The brightest and largest object in the night sky. It is the closest large body to Earth in the solar system. At a distance of only 239,000 miles. The Moon is the only celestial body on which humans have set foot. Exploration of the lunar surface by spacecraft began in 1959 with the Soviet Union's Luna program. Luna 1 failed to land on the Moon. However, Luna 2 did succeed in landing, becoming the first artificial object ever on an extraterrestrial body. Several unmanned lunar probes followed those pioneering missions during the following 10 years. Just a few years later, in 1969, a great milestone was reached. The Apollo 11 lunar module landed 2 astronauts on the Moon. For the first time ever, a human being walked on a celestial body besides Earth.
That's one small step for man, one giant leap for mankind.
Since then, 12 others stepped on the Moon in the different Apollo missions. The last one, Apollo 17, was launched in 1972. It marked the end of the Apollo lunar mission. After that, for several decades, the Moon as a priority target disappeared from the programs of space agencies, and human beings didn't walk on the Moon again. Given the fact that it's so close to Earth, and considering our interest in exploring space, why didn't we go back to the Moon?
This was in a totally different time than we are today. This was in the time of race in space. It was about prestige. It was about showing the power and the possibilities a nation has.
Nevertheless, in 2009, something happened that changed everything and encouraged space agencies and private companies to start once again to develop manned missions to the Moon after so many decades of lack of interest. That year, the Indian Space Research Organization's Chandrayaan-1 probe made a surprising discovery that put the Moon in the spotlight. It discovered the widespread presence of water molecules in the lunar soil, overturning theories that had stood for 40 years.
The Chandrayaan-1 mission was a very special turning point in the exploration of the Moon.
Some of the payloads on that mission conclusively verified the presence of water ice. Just 2 months after that, in November 2009, NASA reconfirmed water on the Moon with its Lunar Crater Observation and Sensing Satellite Space Probe, which detected large quantities of water ice.
We are talking about scooping something, melting it, and water. You know, that makes a big difference to get water that you can drink, that you can live by, water. The Indian mission clearly showed a sign of water, as water, not as composites of minerals or anything like that, just water.
In March 2010, it was reported that the Minisar on board Chandrayaan-1 had discovered more than 40 permanently darkened craters near the Moon's North Pole that are speculated to contain an estimated 600 million metric tons of water ice.
This was quite revealing because for about 30 or 40 years, there's been debate. There's been a growing debate about, is there water on our Moon?
If future research finds large enough quantities of water ice, it could be turned into liquid water for drinking and plant irrigation. It could also be split into hydrogen and oxygen with the energy provided by solar panels or a nuclear generator. The hydrogen might be used as rocket propellant and the oxygen for breathing.
NASA now After the Chandrayaan-1 mission, they've gained the support to put together a mission to go to the surface of the moon. They're going to put a rover on the moon that has the ability to scoop the material and examine it. And I think that will convince everybody that there's a lot of water on the moon.
Nowadays, thanks to this discovery, human beings are thinking of going back to the moon again after many years. In fact, the moon might become our first space colony in the near future. We have the technology and the know-how we need to do it. But what drives human beings to consider settling a colony beyond the Earth? There are several reasons that lead us to suppose that, sooner rather than later, human beings will go beyond the boundaries of the Earth to settle somewhere in the solar system.
We've done this everywhere on this planet. We've colonized every place that we could possibly colonize on this planet. So it's a kind of genetic thing.
The rise in population is causing an increasing need for resources. The Earth is becoming too small for so many inhabitants.
Population on Earth has become a controversial problem now for a long time, starting with the limits to growth movement.
We need to find more raw materials to support our whole population and so that civilization could keep on progressing. Those resources are out there.
There's enough material in the asteroid belt to build beautiful space colonies with a total land area 1,000 times that, the surface of the Earth. A habitable volume capable of sustaining a human population of 1 trillion people, which gives us the promise of humanity expanding, growing, and thriving for at least another 1,000 years.
On the other hand, there are hazards now that lead us to think that we may have to leave the Earth someday. Climate change has become one of the greatest dangers humanity has ever faced and could lead civilization as we know it to its destruction if we don't stop it in time.
We should do exploration because it's in our genes to be curious, but at the same time we should save our planet as much as we can. And through exploration we can learn about our planet.
Undoubtedly, there is in human beings an internal impulse that makes them explore new frontiers. Now, our next step could be the moon. The discovery of water there, an indispensable element for life, was the key factor that lets us consider our satellite as a possible future home. However, the moon is not a hospitable place for human beings. So the challenges that we all have to face to settle a colony there are very great. Despite its proximity, the moon has characteristics that make it a very different place from our planet. First of all, its diurnal period is very different from Earth's.
It depends where you are on the moon, the length of day. If you go to the poles, your day can last most of the year because you're in almost permanent illumination. If you go down to the equator, then you get about 2 weeks. So you know that you've got about 2 weeks of day and then you've got about 2 weeks of night. So it would be a completely different way of living. And you'd probably have to artificially create day and night.
Its gravity is also different from Earth's. While we have a gravity of 1g here, on the moon, it's just 1/6, 6 times less than on Earth. As of today, we don't yet know exactly how this lower gravity could affect human health in the long term. We know that exposure to weightlessness over month-long periods cause deterioration of physiological systems, such as loss of bone and muscle mass and a depressed immune system. Similar effects could occur in a low-gravity environment as the moon's, although it is still unknown.
The moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea. Is it more like having 1g, full gravity, or is it more like having null gravity? We actually don't know. We presume it's a spectrum, that the moon is more like having no gravity than Mars is. Mars is more like having full gravity than the moon is. Those are just sets of assumptions we've made, but we actually have no idea.
Temperatures on the moon, as well, are also completely different from the Earth's, which would condition certain aspects in the functioning of the colony.
You get a temperature swing of several hundred degrees between lunar night and lunar day. The temperature difference is so great, it actually triggers seismic activity.
The frequency and duration of seismic activity on the moon is such that it becomes a serious hazard to the integrity of a permanent base on the moon.
There are a group of moonquakes called shallow moonquakes, and some of these reach magnitude 5 or above. And in terms of Earth, that's reasonable. But when the moon has a seismic event, it keeps on going. It doesn't just last 30 seconds to a minute. The maximum ground motion lasts 10 minutes.
Another of the characteristics that might affect a lunar base is that, unlike the Earth, the moon has no atmosphere to protect us from radiation and other dangers.
Not having an atmosphere on the moon affects several things. First, again, is safety from micrometeorite impact. It comes in faster than a bullet, and you don't want to be in the way of that.
It also leaves the lunar surface exposed to half as much radiation as in interplanetary space, raising the issues of the health threat from cosmic rays and the risk of proton exposure from the solar wind. Apart from that, it's known that the presence of volatile elements on the moon, such as nitrogen and hydrogen, is extremely low. If we are not able to recover these volatile elements, they will need to be imported and recycled for life support in industrial processes. Unfortunately, this fact would serve to limit the growth of the future colony, as it would be dependent on imports. Despite all this, the proximity of the moon offers several advantages that make it the most obvious natural expansion after Earth. The duration of the journey to the moon is short. In fact, the transit time of the Apollo missions was just 3 days. In the near future, the technology will allow us to reduce it greatly. This short transit time would also be useful in case of emergencies, whether to send emergency supplies to the moon or to evacuate a human crew back to Earth.
The moon is a very interesting body. It is close to us. You can reach it in 1 week. You can go to the moon and back if you like.
The short distance causes a communication delay to Earth of less than 3 seconds. So voice and video conversations would be almost in real time and allow Earth-based teleoperation to be a viable alternative to robotics and local human operation, which is not possible on any other planet. The fact that a settler would always see the Earth as a large and much brighter object than the moon appears from Earth would mitigate the sensation of loneliness that those settlers might feel. The moon's lower gravity makes it much easier to launch rockets from the moon, as they would need much less energy than needed to escape from Earth's much higher gravity. Therefore, a lunar base could be a much better location for launching rockets to other planets, such as Mars, using locally manufactured fuel. All these advantages lead many people to see the moon as the most feasible target for a future colony off Earth. Other goals, like Mars or even the asteroids, also have ongoing projects and studies. private companies like SpaceX and Blue Origin and public institutions like NASA are developing projects to soon colonize Mars.
There are developments underway with NASA, like the Space Launch System and the Orion capsule, to put astronauts in orbit around Mars in the 2030s.
Engineers and scientists from all over the world are working toward a new era of manned space exploration.
The moon can be a stepping stone. The moon can be something like learning also logistics. The moon has scientific value, and maybe also for tourists the moon is of interest because you can really do it in summer vacation. And therefore the moon is something also like a stepping stone to go, for instance, to Mars, but it is also an interesting destination by itself.
Its proximity and its special characteristics mean we can consider the moon a good place to settle, and it might become the starting point for unprecedented space industrial development. When it comes to colonizing the moon, one of the key points would be to decide where exactly to settle the colony. The chosen place will largely determine the functioning of the future colony. The potential locations fall into three broad categories: the polar regions, the equatorial regions, and the far side.
That is the main debate. Where do you go on the moon? Currently, we have mapped the entire moon and in very high detail, and we have looked at minerals and the availability of resources all over the moon. We think that the polar regions are probably more promising because there's water in those regions, readily accessible water. And water is the source of life, and if you can find water, if you have water, a lot of other things become easy to do. The polar regions of the moon also have constant sunshine. And that gives you energy, and you have water, and then you can have a permanent colony there.
Another location for a lunar base could be the lunar equatorial regions. They are likely to have higher concentrations of helium-3, rare on Earth, but much sought after for use in nuclear fusion research.
We have on Earth a very favorable situation that we have a lot of resources on Earth, all types of elements. But some of the elements are rare, and some of these elements you can find in our solar system, in asteroids or on the moon. So helium-3 is one of them mentioned, but I learned from scientists that up to now, to produce helium-3 on Earth is cheaper than to get it back from the moon.
Equatorial regions also enjoy an advantage in extra lunar traffic for launching material, as these regions coincide with the lunar orbit around Earth and nearly coincides with the equatorial plane of Earth.
Now we know that if we send a rocket ship from the Earth to the moon, there are certain trajectories called free return trajectories. That is, you don't have to put so much energy to be able to come around. Once you fly out to the moon, you go to the moon and you swing, the moon swings you back to Earth.
However, the great disadvantage of equatorial regions is that they have 2 continuous weeks of night.
That's not viable for us because if we don't have light, we immediately have a problem with storage of power. And if you are in the dark for 2 weeks, that is very hard on a lot of systems. Engineering, tools, instruments, they all freeze.
On the other hand, the fact that the lunar far side is well shielded from Earth makes it a good location for a large radio telescope. The site would be also interesting for an array of optical telescopes because the moon also has no atmosphere.
If you go to the far side of the moon, you have the advantage you are in the shadow of the moon concerning our radiation coming from Earth. You have a stable surface, so you can build a huge installation using moon material, and then you can have a deep view to the universe, and therefore to go on the far side on the moon with a radio telescope is, for scientists, already a very impressive and inspiring activity.
Once we have selected the best location for a lunar base, the next step would be to consider where and how to build to protect from radiation, meteorites, and other possible dangers.
If you're on the surface, you're exposed to solar particle radiation, which is dangerous for our physiology. The temperature extremes, that can be 300 degrees centigrade between the dark and the light. And you also have micrometeorites, which are much faster than speeding bullets. And they shower.
If we want to have astronauts over there, then we have to do something for radiation shielding. There are lava tubes on the moon. Why not using these lava tubes?
The lava tubes on the moon could be a good location for a settlement, as it would be protected from the severe hazards of the lunar surface, such as frequent meteorite impacts, cosmic radiation, and extreme temperature variations.
A lunar lava tube is an old form of flow. It starts on the surface. We see it on Hawaii. The surface solidifies, forms a crust, and the magma keeps flowing beneath that, forms an underground river. As the amount of magma wanes, the eruption dies down, that drains down and leaves a void.
They also have proven themselves as a reliable structure, having withstood the test of time for billions of years.
More importantly, we believe the thermodynamics makes us think that the interior has a steady temperature of about minus 20 degrees Celsius.
All those reasons lead us to think that the first permanent settlement on the moon could be underground. We would be protected from cosmic rays, from solar storms, extreme temperatures, and also from being hit by meteorites.
We also think that once you settle underground, you should not get the feeling that we're going to be there all the time. We would go out and do the science and tourism. The symbolism is clear. When humans started to evolve, we were cavemen. We lived in natural shelters. And it's interesting to me that you'd fly down to a new planet or to our moon, and the first home would be an astronaut caveman. But we have to learn to live outside. I think it's like growing up to be real people. And so over time, I think we'll probably live on the surface of the moon and other planets.
A possible solution would be to construct the lunar base on the surface and cover it with lunar soil or lunar regolith, composed of rock and mineral fragments from underlying lunar bedrock broken apart by the impact of meteorites.
Well, regolith is loose material. It is often mistermed soil. Soil on this planet has organic matter in, and we know the moon does not have that. So it's loose material, loose sediment on the surface that has been formed through meteoroid impact over millennia.
Lunar regolith is composed of a unique blend of silica and iron-containing compounds that may be fused into a glass-like solid using microwave energy.
The regolith can be used as a building material because it can actually manipulate it. You can move it with the dust that gets kicked up with the lunar rover when the astronauts are up there. So you can use a backhoe, if you like, to move it around. So it's one of these features that you can pile up, you can tunnel into, you can mine it, so to speak, but you can use it as a building material. One thing we've learned is that this regolith contains very small particles of metallic iron, and that couples very well with microwaves. So you can actually melt lunar regolith in a kitchen microwave. And so you can sinter that to make it solid. at least a solid surface to cut down dust, but also to make bricks for construction.
Once we know the location, it's time to think about how to construct our first lunar base. As technology and our knowledge of the moon have advanced in the last few years, the design of lunar habitat proposals has also evolved. Concepts vary from the adaptation of landers or their used fuel tanks as habitats to different inflatable modules.
We should have what we call, in our jargon, pre-integrated structures, which are really large spacecraft with everything in it already. You touch down and you turn on the light, you have your office. That's your site office.
One of the greatest obstacles we have found to building on the surface of the moon is the dust.
Lunar dust is very, very difficult. Lunar dust is microns in diameter, made over billions of years of these micrometeorite impacts on the moon that geologists call gardening. It's called gardening, it's a geological phenomenon. And so when this powder is charged by the solar wind, it becomes electrostatically active. So when you wear a nice astronaut garment and step out on the lunar soil, the dust climbs up into your body. It goes between the seals of your gloves and it scratches your visors. And just a few minutes after any kind of work on the lunar surface, your suit is completely smudged. The thermodynamics is completely messed up. You start to have problems because you cannot see. And so dust is a problem. NASA knows this because of Apollo. So my idea was that you would build a complete lunar base in Earth orbit near the space station because it's outside of Earth and there's no gravity. Completely assemble it and fly it as a fully pre-integrated, prefabricated structure, land it on the moon, and you have your habitat.
One of the most interesting ideas is the use of 3D printing technology to build lunar habitats. One of these 3D printing techniques is contour crafting.
There is a technique of building robotically called contour crafting. We can use raw materials from the moon, especially moon dust. We take moon dust, mix it with sulfur or some other compound to bind, and then we compress it like toothpaste and build walls. You can easily build any shape and erect structures using robotic technologies. And you can do this from planet Earth. You don't have to go to the moon to do this. So some of us believe that we can look at what is happening on the moon from Earth and build up structures to such a point that once the basic structure is built, then we can send people there to put things inside the structure.
In addition to contour crafting, another 3D printing concept is one proposed by architectural firm Foster & Partners. These 3D printers would use raw materials from lunar regolith to cover enclosed inflatable habitats for housing the human settlers, which would provide both radiation and temperature insulation. One of the greatest advantages of these techniques is that just 10% of materials for the structure mass would need to be transported, as 90% of it would be local lunar materials.
So we think by doing 3D printing activities and robotic construction technologies, introducing them, we can keep astronauts safe while work is being done. 3D printing has become an established way in a lot of robotic activities, particularly in the building industry.
Therefore, there might be several different types of colonies for the moon. Underground excavated colonies, or inside lava tubes, or on the surface. But all of them have something in common. They all need a source of energy. There are several options when it comes to a source of power for a future lunar base.
If you want to stay on Moon, either with robotics or with humans, you need, of course, energy. You need, most probably, you need electric energy. And there are different possibilities how you can get the electric energy. You can do it with nuclear, you can do it with solar energy, but the simplest is, of course, solar energy because it's free of charge and you do not have to have a big maintenance.
If we want to produce solar panels on the Moon, we could extract many of the raw materials on site. The main difficulty for the use of solar power would be the long lunar night of almost 15 days. One possible solution might be to build several solar power plants so that sunlight would always reach at least one of them.
The source of energy for any permanent moon base is going to be critical. And solar is I would say, the easiest option. There's been lots of talks about nuclear fission reactors, but trying to get a nuclear fission reactor to the moon is a bit expensive and a lot of paperwork involved. But also the fact that you don't have any clouds up on the moon, so when it's daytime, you've got guaranteed 100% energy. Solar energy is the best option.
Another possibility would be the construction of a power plant in an area of constant or near constant sunlight, such as the South or North Poles. A third option would be to use space solar panels in orbit and beam the power down as microwaves. Nuclear fission could be another possible source of energy on the Moon. With just one nuclear fission reactor, we could supply the energy requirements of a lunar base. And the handicap of the 354-hour lunar night wouldn't be a problem at all. Whether it be solar or nuclear energy that is used, how would it be stored?
Energy storage has been a problem on this planet, but right now it'd have to be batteries. It'd have to be either hydrogen fuel cells or just regular batteries. In some of the missions I've looked at, which are robotic missions, we've looked at using solar and then using batteries to survive the lunar night. And batteries are heavy, so it adds mass to your mission, and therefore it adds expense to your mission. So understanding good energy storage is an area of research that really needs to be done.
At the beginning, energy would be provided by a combination of solar panels for daytime and fuel cells for nighttime. Fuel cells have operated on the space shuttle for up to 17 Earth days, so their duration would be enough for the 354 hours, almost 15 days, the length of the long lunar night. To have the supply of a source of energy is a key requirement to settle a colony. But in addition to a reliable source of energy, there is also something vital to making a lunar base feasible: a life support system.
The next step in going back to the moon and beyond is ensuring that we make use of the resources that are available on the moon. And that includes creating life support from the volatile deposits, hydrogen and oxygen and water.
A life support system must be able to sustain humans living in space, allowing them to survive there. It may supply water and food, as well as include monitoring atmospheric pressure, oxygen levels, waste management, and maintenance of correct body temperature.
Life support for a permanent settlement, we see in the movies that there are plants up there creating oxygen and biomass and food, and you would need that. It's been shown from the Apollo regolith that the plants can be grown in it. There's no harmful side effects from growing plant in regolith. The one thing that will be needed is organic matter, because the regolith doesn't contain any.
However, if we want to grow crops on the moon, we will have to overcome difficulties such as extreme temperature variation on the surface, exposure to solar flares, the long lunar night of almost 15 days, and lack of insects for pollination. The fact that the moon has no atmosphere implies that we would need sealed chambers to grow plants there, which wouldn't be a problem as it has been proved that plants can thrive at pressures much lower than those on Earth. One of the main issues with lunar agriculture would be the long lunar night. As the use of artificial light would mean high energy consumption, other sorts of solutions are being considered, such as the use of fast-growing crops that might be started as seedlings with artificial light and be harvestable at the end of one lunar day. When it comes to settling a permanent lunar base, another fundamental need is transport. The moon's distance from Earth is about 239,000 miles. So, one of the first obstacles that must be solved would be to develop a simple means of transport to get there. In addition, a transport system to get around on the surface of the moon will also have to be developed. For the journey from the Earth to the moon, conventional rockets have been used for lunar explorations to date. Another proposed concept of Earth-to-moon transportation are space elevators. This technology would take advantage of the fact that the moon's gravity is much lower than the Earth's.
The idea is very simple, that if you can erect a structure that is so tall that you don't have to have a rocket ship to carry stuff, instead carry it through a tether or an elevator to the destination.
When it comes to the transportation on the lunar surface, proposed concepts include a variety of vehicle designs, from small open rovers to large pressurized modules with lab equipment, and also a few flying or hopping vehicles. For a colony to be considered a colony and to be sustainable in the long term, it has to be nearly self-sufficient. The colonization of the moon could offer interesting business opportunities, as it could be a place for companies to develop products and services, such as a future lunar mining industry. Mining the moon's materials on-site for use both on the moon and elsewhere in the solar system where they might be needed in the future would greatly reduce costs compared to sending them from the Earth, as much less energy would be required to launch them into space.
The kind of things that we would like to see are, of course, a commercial mining infrastructure on the moon and a fuel depot associated with the Deep Space Gateway. It will only enable a trip to Mars if you can store fuel and resources in the vicinity of the Deep Space Gateway.
As the mining business in space develops during this century and human beings become a multiplanetary species, large amounts of matter will need to be launched to several locations in the solar system. Therefore, the moon could come into an interesting option to reduce the costs of interplanetary cargo transport.
If you can then refuel life support in rockets going to Mars and beyond, as well as fuel using lunar resources, you've then reduced the mass you need to lift off this planet. So it becomes an enabling asset not only for lunar exploration, but solar system exploration.
In the near future, the moon will become a key platform providing raw materials to space-based construction facilities. Construction in space, as well as manufacturing and other industrial processes, will increase considerably as zero gravity will make these kinds of processes much easier and safer.
It will make sense to move manufacturing off the surface of the Earth. And as Jeff Bezos says, all the heavy manufacturing will be done in space, and the surface of the Earth will be zoned for light industrial and habitation.
To reduce the cost of transport, The moon could store propellants produced from lunar water at one or several depots between the Earth and the moon to resupply rockets or satellites in Earth orbit. We know that water is a key resource as it can be used to produce rocket propellant and also to produce oxygen, absolutely necessary for colonization and life support. After having analyzed all the key points to be considered when building a future lunar colony, such as the location of the colony, the energy source, transportation, and the economic development of that settlement, we can undoubtedly consider that the building of a lunar base would be one of the greatest technological challenges that humankind has ever faced. Despite the huge difficulty that a lunar base brings with it, there are already some proposed projects in the near future by several public institutions and private companies. The first one was the Lunar Reconnaissance Orbiter, a NASA robotic probe launched in June 2009, and which is currently in orbit around the moon. It has scanned and mapped the lunar surface in very great detail. It has identified safe landing locations, searched for potential resources, analyzed the environmental radiation, and tested new technologies. While the U.S. currently has no firm plans to return to the moon, the European Space Agency, Russia, and China have all expressed interest in building a base there. In fact, the ESA, the European Space Agency, has designed an ambitious plan to settle on the moon in the near future. The Moon Village. It was announced by ESA Director General Jan Warmer in April 2015 during the Space Symposium in Colorado Springs, USA.
The Moon Village is an open concept with free and open access for each and everyone, be it industry, be it the public sector. It is open for robotic activities, it's open for human activities.
The Moon Village is intended not only for scientific and technological activities, but also for activities based on exploiting resources or even tourism.
This is the idea of the Moon Village concept. And I can tell you that now already a lot of different entities worldwide, private and public entities, are interested and bringing different parts, very different parts into this idea. I'm very happy that now also some entities like Blue Origin, Jeff Bezos, but also Elon Musk are announcing that they are interested to go there.
It is clear that in the future, humans will take part in crewed flights farther into the solar system. So the Moon Village could also act as the perfect springboard and testing ground with that objective in mind.
I believe that the Moon Village is already in its development phase. And it's only a question of a month or let's say 1 or 2 years that we really see hardware on the moon belonging to the Moon Village.
The Moon Village would be a first step in the future exploration of Mars, as it would also act as a pit stop. At the beginning, there would be just robots, rovers, and huge 3D printers that should build the modules and habitat where the first astronauts would live in. In addition to the Moon Village, there are other projects led by other space agencies that intend to go back to the moon in the near future. The China National Space Administration has commenced the Chang program for exploring the moon to investigate the prospect of lunar mining, specifically for mining isotope helium-3 for use as an energy source on Earth. The Russian Federal Space Agency Roscosmos has planned a fully robotic lunar base called Lunar Polygon. The project is planned for the second half of the 2020s. Scientists hope that in the near future, we will witness the creation of the first lunar base for human beings. What may become a reality much sooner is tourism on the moon. Some space tourism startup companies are planning to offer tours on or around the moon in the near future.
We do believe that the first really big industry in space is going to be space adventure travel. And so people on vacation will be traveling from place to place in space, and we'll be providing the propellant so they can get to the space hotel and back.
Some individual companies as SpaceX, Virgin Galactic, or Space Adventures estimate that lunar tourism will be a reality sometime between 2020 and 2043. The company Space Adventures has announced plans to take 2 tourists to within 100 kilometers of the lunar surface using a Soyuz spacecraft piloted by a professional cosmonaut. In these future luxury tourist trips, exotic attractions might include the view of the far side of the moon, which can't be seen from Earth, or the view of the Earth rising and setting against the lunar horizon. The interest of several private companies in space exploration is already a fact. The private sector is already working to begin a new era of space exploration.
We should return to the moon as a stepping stone to Mars, but that it should be done commercially with public-private partnerships. We do not need a large government program like Apollo that focuses simply on having human beings walking around on the moon, that instead we need to focus on developing lunar resources to enable eventual trips to Mars.
This collaboration between private companies and public institutions will soon produce great results in the adventure of the colonization of the moon, to later expand to Mars, the asteroids, and other places.
That brings up the next major development in human history. And that is, for the first time, we have extremely wealthy technological entrepreneurs that want to move the needle of history. This hasn't been the case since the late 19th century and early 20th century that led to the massive industrialization and improvement in wealth all around the world in the 20th century.
This might be the first step of a new era. An era in which the Earth would no longer be our only home. On July 20th, 1969, at 10:56 p.m., Neil Armstrong became the first human to step into another world, the moon.
It's one small step for man, one giant leap for mankind.
We may possibly witness such an epic moment on Mars very soon.
From a technical point of view, we're much closer today to being able to send humans to Mars than they were to being able to send men to the moon in the 1960s.
This might be just the prologue to one of mankind's greatest challenges, settling on a world away from Earth. a space colony on Mars might become a reality in the near future. The Earth might well become uninhabitable due to climate change or the impact of a huge asteroid.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
The only way to guarantee the survival of our species may be to create a new home off Earth. The amazing discovery of huge amounts of water has boosted interest in Mars, putting it in the spotlight. NASA and ESA, the European Space Agency, and private companies such as SpaceX are already working on projects for settlements on the Red Planet in the coming decades. But it won't be an easy road. Mars is so far from Earth that the spaceflight would be about 6 to 9 months, involving long exposure to cosmic radiation and zero gravity. We will also need to overcome the engineering difficulties of landing on Mars due to its thin atmosphere. That future colony on Mars will need effective shielding, as the ionizing radiation that reaches the surface is extremely high and would be lethal.
The atmosphere is so thin that if you were not protected by a spacesuit and by accident you were exposed to the atmosphere of Mars, your blood would boil instantaneously.
All those difficulties make the construction of a permanent settlement on Mars a huge, unprecedented technological challenge.
This is a game where you have to do everything right and roll 7-11 or doubles.
Our descendants, who might live on Mars, will remember the moment they established the first space colonies as one of the greatest milestones of humanity. Since human beings first ventured into space, they have dreamed of being able to live on another planet. Among all the planets of the solar system, there is one that is considered one of the best targets for possible human colonization: Mars. Its surface conditions and the presence of water on Mars make it the most hospitable planet in the solar system, other than Earth.
Mars is the most similar planet in terms of environmental circumstances, and it is the one that has the most resources to support human settlement.
Since the first close-up pictures of Mars by Mariner 4 in 1965, several NASA spacecraft voyages to the Red Planet have revealed a very familiar world.
If you look at the landscape on Mars, it looks like Australia or Arizona. It's a red-colored rocky desert with a lot of sand, and we have that in many places on the Earth.
Like Earth, Mars has polar ice caps and clouds in its atmosphere, seasonal weather patterns, dunes, mountains, canyons, and other recognizable features. This similarity of our neighbor planet to Earth have aroused the curiosity of the scientific community and kicked off a whole series of missions. Since the 1996 launching of the Mars Global Surveyor probe, NASA has developed the Mars Exploration Program. The goal of this program is to provide scientific information through a series of robotic orbiters, landers, and mobile laboratories. The first aim of that program was the program's science theme, Follow the Water, as the water is a key factor for life as we know it.
On Earth, there's a one-to-one connection between life and liquid water. And so instead of looking for life directly, NASA's doing with its partners the easier thing first, which is to look for water.
Several missions from 2001 to 2007 made progressive discoveries related to evidence of past and present water in the geologic record that make it possible to take the next steps toward finding evidence of life itself.
I want to find out if there is alien life there. And of course, not big aliens, tiny little microbes, because it would be the first example of an alien form of life that we would find. And Mars is a good place to go look for that.
In 2011, NASA's Curiosity rover marked a transition between the themes of follow the water and seek signs of life. In addition to landing in a place with past evidence of water, Curiosity was seeking evidence of organics, the chemical building blocks of life. The ExoMars mission, a mission of the European Space Agency, ESA, in collaboration with NASA and NASA's Mars 2020, will finally try to discover if there is or has ever been life on Mars by searching for life itself in places identified as potential habitats. Finally, the third phase of the NASA's Mars exploration program is to prepare for human exploration.
And that already started. We are already planning the human exploration of Mars. I personally hope that it will happen in maybe the late 2030s.
This first manned mission to Mars will mean a milestone for humankind, as was the 1969 moon mission. When this happens, we will be able to say that our path to the colonization of Mars will have started. Human beings' curiosity and passion for exploring new worlds knows no limits. We always want to go beyond our boundaries. The origin of this impulse answers the need of the species to find new habitats that encourage its development. Now, our next frontier is beyond the Earth. Space colonization is the next logical link in our evolution as a species. Beyond the Earth, there are a huge number of resources that we could benefit from to keep growing.
This is a way that the human population can grow and thrive for thousands of years. We can clean up the biosphere, and humanity can expand into the solar system.
Space expansion and colonization might be the beginning of a new era for humankind to reach an unprecedented level of development. In addition, it could be the only way to avoid its destruction by external causes or even self-destruction. The choice could be, as H.G. Wells said, the universe or nothing. Climate change has become a serious threat to our civilization, and we are already starting to suffer its first consequences. Another threat, the danger of an asteroid impacting our planet, is real, and depending on the size of the asteroid, the consequences could be catastrophic.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
It's not likely to happen tomorrow or even in our lifetimes, but it is definitely going to happen sooner or later, and so it would be best if we were prepared for that.
A permanent base beyond the Earth would guarantee not just an alternative home in case of need, but also access to a huge number of resources out there. Mars, due to its characteristics, is considered one of the best possible places for that future permanent base off Earth. Other places like the Moon or the asteroids are also considered possible targets when it comes to taking the first steps toward becoming a multi-planetary civilization. Several private companies are developing projects to extract resources and rocket propellant from asteroids. What is more, the discovery of water on the Moon has led to the development of concepts such as the Moon Village, proposed by ESA, the European Space Agency, to carry out activities based on the exploitation of resources and scientific research. Nevertheless, to establish a permanent colony that may become a future home for human beings, Mars offers several advantages over the Moon or other places. Mars is bigger than the Moon and also has more resources that we could take advantage of. So it's better suited to improvements to turn it into the home for a self-sustaining civilization. While the Moon has no atmosphere at all, Mars has the advantage of having some atmosphere, composed primarily of carbon dioxide, about 96%, with other gases such as argon and nitrogen, which means we can grow plants just by compressing the atmosphere.
Mars has water, frozen as ice, and permafrost in the soil, but nevertheless there in large quantities. It has carbon dioxide, atmosphere, which is carbon and oxygen. It's what we need to make fuel. It's what we need to grow food. It has nitrogen, which life also needs. These things are extremely rare or completely absent, for example, on the Moon.
If we compare our own planet to Mars, they are surprisingly alike in many ways. Conditions on the surface of Mars are closer to the conditions on Earth in terms of temperature and atmospheric pressure than on any other planet or moon.
The temperatures get to about 20 centigrade in the daytime at the equator, which is entirely acceptable. At night, it can get very cold, but it's not difficult to shield against cold by wearing a heated spacesuit. As different as they are from Earth, the conditions on the surface of Mars are acceptable for human exploration and settlement.
Mars, in comparison to the Moon, has gravity more like Earth's. While the Moon's gravity is 1/6 of the Earth's, Mars is 1/3. Thanks to studies done at the International Space Station, the only available laboratory of zero gravity, we know that the lack of gravity is a health problem in the long term. We suppose that having gravity much closer to Earth's will be favorable to settling a colony. A lunar day is 28 Earth days, whereas the Mars day is 24.5 hours, almost identical to Earth's. Also, Mars is about half as far again from the Sun as Earth is, so it still has acceptable sunlight. All these similarities between the two planets have led NASA and several private companies to start development of projects for manned missions in the near future. The NASA program Journey to Mars has been gathering data for several years, leading to a radical increase in our knowledge of the Red Planet and paving the way for future human explorers. Furthermore, private initiatives by aerospace transport companies such as SpaceX work with a clear goal: to colonize Mars.
That could take several generations of crews. Maybe the first mission will just set up the greenhouse, and then the second mission might start growing a few plants, but experimentally, They might eat them, but they're not going to rely on them. And then maybe it's only with mission number 10 that we'll stop bringing food from the Earth, and we're really going to count on the food that we're growing on Mars.
To establish a permanent settlement on Mars won't just require a great deal of time, but will also mean huge technological challenges. Despite the surprising similarities to Earth, Mars is a hostile place for life.
As soon as you dig a little bit deeper, you realize that Mars is actually a very different planet compared to the Earth. It's actually lethal for human beings and most life forms that we know of on the Earth.
Human survival on Mars would require complex life support measures to be able to face the difficult conditions for life there.
The atmosphere is so thin that your blood would boil instantaneously. You would die of depressurization within seconds. If that did not kill you, well, the atmosphere is unbreathable. It's made of carbon dioxide. We need oxygen to breathe. That would kill you within minutes. If that did not kill you, then the dust on Mars is very fine-grained, very abrasive, cutting, and also toxic, chemically toxic. That will kill you in a matter of several weeks.
One possible suggestion for making Mars conditions acceptable for the human beings would be to transform the planet, adapting it to the needs of human life. A concept that has been called terraforming. Terraforming would be a process of planetary engineering that allows the creation of a local biosphere similar to Earth's, making the red planet a habitable place for human beings.
The idea is to transform Mars into the Earth, to make the atmosphere thicker, to make the planet warmer with a warmer climate, to, over time, transform the composition of the atmosphere from what it is today, CO2, carbon dioxide, into oxygen.
Many scientists using climate models and ecological theories conclude that the terraforming of Mars is a feasible idea. With present technology, the climate of Mars could be transformed, making it capable of supporting life. Mars is now very cold, overly dry, and its atmosphere of carbon dioxide is too thin to sustain life. But these parameters are interlinked, and the three of them can be altered by a combination of human intervention and biological changes. If we could warm Mars up, we would once again have a thick atmosphere and liquid oceans.
It takes a long time to progressively thicken the atmosphere, transform the climate into one that that's warmer, and then over time change the chemistry of the atmosphere and make it oxygen-rich. We're not talking about decades, we're talking about many centuries, and it would be very expensive to do.
One strategy to warm Mars would be to use orbital mirrors placed in orbit around Mars to increase the total sun exposure it receives. This would direct sunlight onto the surface and could increase Mars's surface temperature directly.
What you have to do is heat up the surface using mirrors in space to get some of the trapped water ice and the carbon dioxide back into the atmosphere.
The other strategy to raise atmospheric temperature would to provoke an artificial greenhouse effect.
We know about gases that are much more powerful than carbon dioxide as greenhouse agents. And these are like fluorocarbon gases. And we could produce these artificially on Mars. On Earth, we do produce these things, we use them for refrigerants. On Mars, we would just release them into the atmosphere. If you warm the planet, it will come out of the soil and it will thicken the atmosphere with massive amounts of carbon dioxide, which we know is also a greenhouse gas. And that would turn the 10 centigrade rise into a 50 centigrade rise. Now, if you had that, then what you would have is really Earth-like temperatures on Mars. And it means that the water that is frozen into the Martian soil would melt and start to flow again.
Unfortunately, terraforming Mars is a solution that would require a great deal of time and a huge investment. Therefore, if we want to build a first permanent base there, there is no option other than to face the challenges involved for human beings to be able to live on Mars. One of the principal challenges among them is to protect against radiation. Radiation is a natural phenomenon that could cause severe damage to human beings by seriously affecting their DNA. The Martian surface has high levels of radiation due to its very thin atmosphere and lacks Earth's global magnetosphere. In addition to this, from time to time there are solar proton events that produce much higher doses of radiation.
Mars doesn't have a magnetic field, so galactic cosmic rays get through the thin atmosphere, solar flares, some of that gets through, and it can disrupt the DNA. So you need a habitat that shields the astronauts.
The Mars Odyssey spacecraft measured this cosmic radiation. It found that radiation levels in orbit above Mars are 2.5 times higher than at the International Space Station. A 3-year exposure to such levels would be close to the safety limits currently adopted by NASA. The effects on living organisms have been closely studied. Protons from cosmic radiation may cause twice as much serious damage to DNA as previously estimated, exposing astronauts to greater risk of cancer and other diseases. NASA is exploring a variety of alternative techniques and technologies, such as plasma deflector shields, to protect astronauts and spacecraft from radiation. Nevertheless, a 100% effective technique has not yet been developed. Another of the main challenges when it comes to sending manned missions to Mars is the huge per-person cost of the trip. In fact, it would not be at all feasible to create a self-sustaining civilization at its present cost. There are estimates, with the Apollo program as a reference, that calculate the present cost to be around $10 billion per person. It's essential to reduce this cost to undertake the building of a permanent base. This is precisely the goal set by SpaceX company.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that involve to just go for it.
According to Elon Musk, to make Mars trips possible on a large enough scale to create a self-sustaining city, the key factors are full reusability of rockets, refueling in orbit, propellant production on Mars, and choosing the right propellant. Full reusability is essential and truly the most difficult one.
That's very important. You know, up till now, we've been throwing these rockets away after one flight. Imagine how expensive airplane flight would be if you threw it away after each flight. Boeing 747 seats 400 people, costs $400 million. If they had to throw it away after each flight, an airplane ticket would be $1 million a flight.
The next goal would be the development of a system to refuel spaceships in orbit. The ships would have dry tanks on leaving the Earth. This would help to reduce the costs radically. Finally, the third factor that Elon Musk stresses is the ability to produce propellant on Mars so that spaceships can return to Earth, as well as choosing the right propellant. The surprising advances that SpaceX is making indicate that they will soon be able to reduce the costs of the trip considerably. But sending a manned mission to Mars would still mean solving very important questions, such as being able to make a safe landing.
Landing on Mars is tricky. First of all, you use an aeroshield to slow yourself down from orbital speeds to subsonic speeds, and then you pop a parachute, and that brings you down to a slow velocity, and then you have to then do the final landing with rockets.
The relatively strong gravity and the presence of aerodynamic effects makes it difficult to land heavy, crewed spacecraft with thrusters only, as was done with the Apollo moon landings. Yet the atmosphere is too thin for aerodynamic effects to be of much help in aerobraking and landing a large vehicle.
On Mars, you have to go through the atmosphere. And the atmosphere is not your friend. Right? So when you're coming in at high velocity, you have to shed a lot of that energy to slow down. So you have an aeroshield.
Landing piloted missions on Mars will require braking and landing systems different from anything used to land crewed spacecraft on the Moon or robotic missions on Mars.
The biggest payload we've landed on Mars has been about 1 metric ton. And for human missions, we need to have at least 10 metric tons landed, and preferably 20 or 30. So we're going to have to scale up.
The improvement of safe landing techniques on Mars is, then, a priority. The NASA's project Journey to Mars will investigate the entry, descent, and landing techniques needed to reach the Martian surface, which will guarantee the success of the first manned mission scheduled for the 2030s. NASA has also already started to study closely what the best location for our first home on Mars would be. These should be locations of high scientific value that would also provide resources to allow human explorers to live on Mars. Local natural resources such as water and oxygen are crucial for humans to explore Mars. Liquid water might be obtained from 3 sources: ground ice, which would be buried or beneath the surface, the atmosphere, or hydrated minerals. Oxygen, by comparison, can be generated from the carbon dioxide that makes up most of Mars's atmosphere.
There's a lot of disagreement about where the Mars base should be. The poles have an advantage because there's water ice there. But the problem with the pole is it's dark for half a Martian year, which is, say, almost a full Earth year. So that leaves you either with the equator regions or the mid-latitudes. They both have something to argue. The equator is the warmest, varies the least with season. But if you go to mid-latitudes, you can get places that always have at least some sunlight all year long, but which have some water ice too. Not big fields of it like the pole, but nevertheless deposits of water ice that are readily accessible.
My favorite site, we call it Noctis Landing, and it's in the western end of Valles Marineris, which is this giant canyon that cuts the surface of Mars. I love this location because it's at the bottom of the canyons, but at the same time it's in an area that's very wide and very open, so that you can see the Earth easily in the sky and maintain communication.
Other possible places considered for a first location on Mars are paradoxically outside the planet. They are the small moons Phobos and Deimos.
The Martian moons are the sweet spot when it comes to a potential settlement site.
We should use Phobos and Deimos as targets. We should send first early crews just to make sure we can travel to Mars and come back safely, not to get too complicated. That will be already a fantastic adventure.
Both of them are much smaller than our moon. Phobos' mean diameter is 14 miles, and Deimos is just 7 miles, while our moon diameter is around 2,100 miles. The fact that they are much smaller means their gravity wells are almost non-existent. So landing and takeoff would be much easier than on the Martian surface.
The Martian moons are locked like our moon. They always keep the same face facing Mars. So if you wanted a place to explore Mars robotically, the best place to do that from is from the Mars-facing side of Deimos. Deimos is 20 times closer to Mars than our moon is to the Earth. So the round-trip light time to control things telerobotically is just a little more than 100 milliseconds.
These two little moons, so very close to the planet, might be used as a pit stop for the exploration and future colonization of Mars, and even for the colonization of the asteroids of the main asteroid belt in orbit between Mars and Jupiter.
I think that they are very exciting places as a first step for humans to explore Mars. The very first missions to Mars, I think, should not try to land on Mars.
Once the location for our first settlement on Mars has been selected, the next step would be to decide which type of habitat to build so that the future inhabitants will have a safe place to live. The astronauts who walk on Mars for the first time may stay there for several months. As the Martian surface has extreme temperatures and the atmosphere is unable to protect them properly against radiation, they will need to have effective shielding against the hostile environment of Mars. NASA, with its program Journey to Mars, has started to explore different construction solutions. One of the most innovative concepts for sustainable habitation on the Red Planet is called Mars Ice Dome, which was designed for NASA by the company's Space Exploration Architecture and Clouds Architecture Office. This ice dome would be built using the most advanced 3D printing techniques. The Mars Ice Dome is a large inflatable structure surrounded by a shell of water ice. Water ice is an effective shielding material for galactic cosmic rays, and many areas of Mars have it in abundance just below the surface. So water ice is a great solution for building habitats on Mars. The Mars Ice Dome structure is lightweight, so it could be easily transported and deployed with robotics, then filled with water before the crew arrives. Another interesting aspect of the Mars Ice Dome is that the translucency of the ice washes the habitat with daylight, connecting the inhabitants to natural diurnal cycles and also lets them enjoy the views. Other construction solutions that involve burying the habitats before the crews arrive would require heavy robotic equipment that would need to be transported from Earth, which would make costs rise significantly. The Mars Ice Dome instead balances the need to provide protection from radiation without the drawbacks of an underground habitat. However, to make it possible for human beings to live in a hostile world like the Martian environment, we are going to need more than just a safe habitat. The colonization of Mars will also require a wide variety of equipment to provide services directly to humans and production equipment used to produce food, water, breathable oxygen, and energy. The first step will be to have life support technologies to recycle air, water, and waste in a closed recycling system and to utilize in situ resources. NASA is already providing advanced life support research and development of innovative technologies.
There are two ways to make the life support for a Martian habitat. You can either do biological or physical chemical. The physical chemical system is, frankly, simpler to implement and more reliable, and it's probably what we'll do first. What that does is it takes the water, the used water, and it purifies it and recycles it so you can recycle your water. That's the most important thing.
Nevertheless, for medium and long duration missions, the life support system should be bioregenerative. a system that incorporates biological components in the synthesis, purification, and regeneration of basic life support commodities. It must be designed in such a way that the components are recycled or regenerated and don't need to be resupplied.
Which is using plants, and that's how the Earth does it. The way the Earth's life support system is that we breathe out water and carbon dioxide, and plants turn that into food and oxygen. And ultimately, that's what you're going to want. On a Martian settlement, we're going to want to set up greenhouses, and we will take the carbon dioxide that we breathe out and some of the water that we produce, and we will use it to grow plants. And they'll turn it back into oxygen and into food for the colonists to eat.
Those greenhouses will need a reliable source of energy that keep the functioning constantly. In fact, a source of energy for the general supply of the colony will be another key factor.
The energy source for growing plants on Mars is going to be Martian sunlight. The solar flux on Mars at the equator is about the same as that on Norway on Earth. If you go to Norway, there are forests, plants grow there, and it's enough. It's enough light to grow plants. Now, of course, the human colony needs more energy than that, just as we need more energy than just outdoor lighting in the daytime, which we use to grow our crops here. And you have basically two choices at first, which is solar energy or nuclear energy.
The issue with the solar energy on Mars is that it is not totally reliable. A sandstorm could reduce solar energy for months, which could be fatal for the colony. For a permanent settlement there, we probably need to develop the Mars geothermal potential. But for a first base, the energy supply would be taken care of with just a small nuclear reactor. For any kind of colony that we are able to settle on Mars, we will need to study the different options of communication with Earth, made difficult because of the huge distance between the planets. NASA and ESA included communications relay equipment in several of the Mars orbiters, so Mars already has communication satellites. While these will eventually wear out, additional orbiters with communication relay capability are likely to be launched before any colonization expeditions are mounted. The one-way communication delay due to the speed of light depends on how far Mars is from the Earth. This delay makes real-time communication, such as telephone conversations or internet relay chat between Earth and Mars, highly impractical due to the long time lags involved.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
This blackout could be solved by using a future network of communication satellites, which would be a realistic solution for a full colonization program. There is no doubt that becoming an interplanetary species will require unprecedented technological and scientific effort. We know that to send a manned mission to a planet as distant as Mars will mean facing countless risks. Before the first human walks on Mars, a group of robotic exploration rovers such as Spirit, Opportunity, and Curiosity could be the outposts that pave the way and could help locate resources, such as groundwater or ice, that would be fundamental for the growth of the colony. The next step would be the progressive arrival of several robotic cargo missions to transport the equipment, habitats, and supplies. They should operate long before any manned mission. It's possible that this first settlement will be a scientific station to be able to do detailed in situ research into the Martian environment.
What I think we should be doing altogether, humanity, is to build an international research station at the surface of Mars, a bit like the International Space Station, but on the ground on Mars.
At present, several nations and organizations are developing long-term plans to send manned missions to Mars. NASA kicked off the Mars mission program with the launching and testing of the Orion Multi-Purpose Crew Vehicle in 2014. The Orion is the first manned spacecraft intended to go beyond the low Earth orbit into deep space since the Apollo program. It has two modules, the Launch and Splashdown Crew Delivery Vehicle and the Deep Space Habitat Module, where the crew will live during the 16-month-long journey from Earth to Mars and back.
It's a good design. Now, it was designed to be bigger than Apollo, so the crew could be a little larger. It's designed to have a multi-purpose destination.
The first manned Mars mission is currently scheduled for the 2030s. On this pioneer mission, the astronauts will be able to orbit Mars for the first time ever and then return to Earth. Therefore, on this first mission, no walk on Martian soil is planned. In addition to NASA, other space agencies have different plans for the future exploration of Mars. ESA, the European Space Agency, through the Aurora program, has a long-term goal for the robotic and human exploration of Mars, with the hope of finding traces of life. It has already sent robotic probes like ExoMars in 2016 and plans to send the next probe in 2020. India, Japan, China, and Russia also have different robotic missions to explore Mars to be launched in the coming years. China and Russia plan to send humans to Mars in the 2040 to 2060 timeframe, but they are still long-term plans that could vary in the near future. Therefore, the only national space agency that has the clear goal of sending humans to the Red Planet is NASA, through its ambitious plan Journey to Mars for the 2030s. In 2015, NASA announced the launching of this enthralling plan, a program for human exploration and colonization of Mars. Journey to Mars that will culminate in a permanent settlement there. It has 3 different phases: Earth-reliant, proving ground, and Earth-independent. The first phase, the Earth-reliant exploration, started a few years ago and should last till 2020s. It's focused on research aboard the International Space Station to study the effects of the lack of gravity on the human body during long-duration space missions. The second phase, called Proving Ground, will test the capabilities needed by future Martian pioneers to live on Mars through several missions operating near the Moon. This phase will last till 2030. In the first of these missions, the Orion spacecraft will travel without astronauts thousands of miles beyond the Moon for 3 weeks. The next step will be a similar mission, but with astronauts inside the Orion. This crew will reach a milestone never achieved in the history of mankind. They will travel further from Earth than any humans have ever traveled before.
The Orion is bigger. That puts some challenges into it, but it'll be able to carry a little larger crew, and it has this multi-destination mission design for it. But again, to land anywhere still is going to require another component.
Also in the 2020s, they'll send astronauts on a year-long mission to test and verify survival in deep space as the final step before our arrival on Mars. Finally, the third stage, Earth Independent, has as its ultimate goal to send humans into low Mars orbit in the early 2030s. To reach this goal, they will need to test the techniques of entry, descent, and landing on the Martian surface. and analyze how to use the in situ resources. Science missions are now very advanced, as there are plans for a new exploration rover for 2020 and a round-trip robotic demonstration mission that will bring samples of Martian soil to Earth in the late 2020s. In addition to different space agencies, interest in sending manned missions to the Red Planet, there are also several non-governmental organizations and private companies that have shown the clear intention of making the colonization of Mars a reality. One of the most proactive organizations is the Mars Society, which is dedicated to human exploration and settlement of Mars and has supported Mars analog research stations in Canada and the United States. Its president, Robert Zubrin, is a confirmed enthusiast of Mars colonization, as he is sure that nowadays technology is advanced enough to achieve it.
I think we could see Mars colonization in our time. We could see it much sooner than most people think. From a technical point of view, we're much closer today to being able to send humans to Mars than they were to being able to send men to the moon in the 1960s, and we were there 8 years after Kennedy's speech. Okay, if we had a president who made a similar bold and brave commitment as Kennedy and stuck with it, we could be on Mars by the end of his or her second term.
One of the most advanced private projects which is considering a self-sustaining human colony on Mars is the SpaceX project. The Space Exploration Technologies Corporation, the so-called SpaceX, is an American aerospace company founded in 2002 by Elon Musk, Tesla Motors CEO, and former PayPal entrepreneur, with the long-term goal of developing technologies that will allow a human settlement on the Red Planet to become a reality. Their ultimate aim would be to create a self-sustaining community, not just an outpost, that could grow into a city. To achieve it, Elon Musk states that an essential condition is to radically reduce the costs of the trip. As with the present costs, it would be totally impossible. According to Musk, the key factors to achieving lower costs would be the full reusability of the rockets, refueling in orbit, and propellant production on Mars.
SpaceX started by proving that they could develop space hardware at 1/10 the cost and 1/3 the time of the mainstream aerospace contractors.
SpaceX's plan is to create a Mars colony with a sustained population of 1 million people, which would mean 10,000 trips there with 100 people per trip in a time frame of about 40 to 100 years. The spaceship is designed with a crew cabin on top and a cargo compartment underneath, with capacity for 450 metric tons of cargo per trip. The duration of the trip would be about 80 days at the beginning, with the goal of reducing trip time to 30 days in the future. If all the plans are achieved, we would be witness to the arrival of the first crewed flight to Mars in about 10 years' time. Until that incredible milestone is reached, the goal is to send cargo from the very first trips to Mars from now on.
Musk might be able to do it. He's going to have to be lucky, okay? He's very brave, he's very determined, but this is a game where you have to do everything right and roll 7-11 or doubles.
Thanks to unstoppable technological advances, the settlement of a Mars colony is no longer the realm of science fiction. but a feasible reality. In the coming decades, we might be landing, working, and living on Mars. This could be just the beginning of the interplanetary expansion of the human being in the solar system. Maybe in a not-so-distant future, our home will be in a very distant place, in one of those remote space colonies.